Picking back up with problem number 31, construct the cumulative frequency distribution for the given data. So what is a cumulative frequency distribution? Go to your textbook, you can search for that. And there's cumulative frequency distribution. Alright, and with a cumulative frequency distribution, see, instead of having the classes that have from 50 to 69 and from 70 to 89, we have the first class is less than 70. So there are two of those. Less than 90. Now remember, less than 90 includes less than 70 and then everything, I guess, that is less than 90 but greater than 70. Greater than equal to 70 and less than 90. So each time your frequencies are going to accumulate. They're going to get larger and larger and larger because you're adding more and more to that running total. Alright, so for this problem, less than 30, so we want to take 26. Put 26 in the table. Alright, less than 40, that's going to be the sum of the first two classes. So that's 26 plus 34, 60. Less than 50, that's going to be the sum of the first three classes. So 26 plus 34 plus 15, 75. Less than 60, so we have, two more. So 75 plus 2, 77, and so on and so forth. Just fill out the rest of the table. Use the given qualitative data to construct the relative frequency distribution. The 2,288 people aboard a ship that sank include 104 male survivors, 1,439 males who died, 375 female survivors, and 73 females who died. And so to get the relative frequency, you just take 401 and divide by the total number of people on the ship, 2,288. So I think we're going to search for a calculator. So if I say 401 divided by 2,288, that would give me 0.175. So if you change that over to a percentage, that would be 17.5%. And you do the same for each of the other. For the males who died, you say 1439 divided by 2288. Change it over to a percent, and so on and so forth. Take the rest of these. Class width is found by, well, think about what width is, how wide something is. Class width is like an interval. And so the way that you can figure out the width of the classes is by subtracting a lower class limit from the next consecutive lower class limit. So like, see these lower class limits and upper class limits here, you could just say 70 minus 50, you get 20, or 90 minus 70, you get 20, or 110 minus 90, you get 20. That's the class width. The following frequency distribution analyzes the scores on the math test. Find the class midpoint of the scores, interval 40 to 59. So class midpoint, all you need to do is say 40 plus 59 and divide by 2. So 49.5. the following frequency distribution analyzes the scores on a math test. Find the class boundaries of scores interval 80 to 99. So you just say, you can say 20 minus, let's see, class boundaries, so not class width. Class boundaries, the way that you do those is you look at a higher or an upper boundary and a lower boundary, and you see how many units are between those two. On this, it's just 1 unit. Take that 1 unit and divide by 2, and you get 0.5. So the way that you get the boundaries for any class is you go 0.5 before the class started and 0.5 after the class started, or after the class ends. So if you were just say 80 minus 0.5, you get 79.5. If you say 99 plus 0.5, you get 99.5. Again, take the unit between an upper class limit and a lower class limit. See what the difference is. On this problem, it's 1 unit. Then you'll take what that distance is, or ever how many units it is, divide by 2. So on this one, we get 0.5. To get the class boundaries, subtract 0.5 from the lower class limit and add 0.5 to the upper class limit. Find the class midpoint. So class midpoint, you'll say 80 plus 99 and divide by 2. 89.5. The histogram to the right represents the weight in pounds of members of a certain high school debate team. How many team members are included in the histogram? So here's their weights down here. Here's how many were in each class. Like between, this starts at 110 here. At 110, you see there's 2. In the 130 range, there's 0. 150, there's 2. 190, 4. 210, 1. And 230, 4. So add up all those numbers. So 2 plus 2 is 4. Plus 4 is 8. Plus 1 is 9. Plus 4 is 13. What is the class width? Alright, of this represents high school programming team. And we know the class width. What are the approximate lower and upper class limits? Alright, to get a class width from a histogram, look at the numbers on the horizontal scale here. You just say 130 minus 110, or 150 minus 130, 170 minus 150. That gives you the class width. So you can see it's 20. Then the approximate lower and upper class limits. Alright, this is the first class right here. Then the smallest value on the horizontal axis is 110. And then see right here where this other bar would start is where the first bar ends. That will be the upper class limit, 130. So 110 to 130. Alright, frequency distribution below represents frequencies of actual low temperatures recorded in the course of a 31-day month. Use the frequency distribution to construct the histogram. Do the data appear to have a distribution that is approximately normal? Approximately normal means that when we grab it, the histogram is going to start out low and then it's going to go high and then it's going to come back low. Alright, so these graphs are kind of small here. But what you can do is from 39 to 44, that'd be like the first class, there's only 1. So you know you should start out at with a really small bar. Well, B starts off with a really big bar. 10 has a really big bar. I'm sorry, C has a really big bar, and D, it starts off with a small bar, but notice there are gaps there. You don't want gaps in our histogram. So this is the only one that it can be is A. And then, is it approximately normal? You start off low, the bars get bigger and bigger until you're in the middle, they're high, and then back down low again. So that's how you can tell if a histogram represents a distribution that is approximately normal. Starts off low, goes high, then back down below again. A nurse measured the blood pressure of each person who visited her clinic. Following is a relative frequency histogram for the systolic blood pressure readings for those people between 25 and 40. The blood pressure readings were given to the nearest whole number. What class width was used to construct the relative frequency distribution? Class width, you look at this horizontal axis and you'll say 110 minus 100, or 120 minus 110, or 130 minus 120. All of those give you the same value, 10. That's the class width.